Hi, my name is Ahmed Sheikh, and today the Academy of Higher Learning presents you a lecture on properties of limits. This lecture is about properties of limits, as its title states, which can be helpful when solving limits for nasty functions, nasty long functions. So let's look at some properties. Some of them are pretty basic, like for instance this one. So limit, you might have seen this somewhere. A C approaches any constant will always equal a constant, regardless of what the a value is or what the c value is. So, for example, would be limit as x approaches 2 and of 5 equals 5. Now, why is it that? Because let's look at the graph. It's just of x equals 5. So the graph is something like this. So no matter what the x value is, it's 5. That is why the limit of a constant will always be of that constant. So if this is 2, then it's 5. It's approaching 5 regardless. And same thing here, here, and so on. Another limit that is pretty basic is, which you might have already used without realizing, is limit as x approaches a for x of x equals a. And like I said, the example would be limit as x approaches 3 for x equals 3. And we can see that basically what you do is sub in the x for the value. And we can see that by looking at the function. So this is f of x, and at 3, so x equals 3, y approaches 3. I know it does not look like that function, but yeah. Okay, so those are the first two properties. Just after that, it kind of gets like a bit. You need to use a bit of thinking. So the other properties are limit. Okay, sorry about that. Okay, so limit as x approaches a, f of x to the power of, for f of x, function of x to the power of n. So what we can do with this limit is pretty much we can take out the power and we can put it outside the entire limit. So that also is equivalent to limit x approaches a for f of x outside bracket, big bracket, to the power of n. So an example, like I'll use a pretty simple example like last time. So say we have limit x approaches 3 to x squared. So let's say f of x equals x. We can simplify that to using this limit now and make it, we can put out the 2 limit, wait, that's 2 does not go here, x approaches 3 to the limit of for x to the power of 2, and pretty much we already solved for the limit over here. So as x approaches 3 for the function of 3, the limit is 3. So we know it's going to be 3 square, which ends up equaling 9. And the the fourth limit property is the constant inside. So if say we have limit x approaches a for a function constant multiplied by a scalar times f of x. This is not right. So what we can do is take the constant and put it out at the front. So that will equal limit as x approaches a times c f of x. So let's use the same example as like we've been doing for before. So limit as x approaches 3. How to restart. As x approaches 3 for say 3x. So what we can do is like take out the 3 and put it at the front. And when evaluating, we take it out. X approaches 3 for x, and we already know that equals 3. So it's 3 times 3, and thus it equals 9. Simple. Then it gets a bit tricky. Well, not really, but it's still pretty simple. You just need to think about it. So say we have limit as x approaches a, and there are two functions now inside, f of x plus g of x. So it's really hard to solve for the limit when the functions are inside. So what we can do is we can use one of the properties where we can like do it separate for each one. So we can put the limit inside the f of x and do it separate for f of x and g of x and add the two limits together. So there will be a limit as x approaches a for f of x plus limit as x approaches a for g of x. So let's go with the example, like usual one. So say we have limit x approaches a, x approaches 3, sorry, for x and plus x squared. So now we can simplify that by using this property and say that limit x approaches 3 for x, and we can split that up for the x squared. X approaches 3 for x squared, and we can simplify that even further as we did before by bringing the square outside the limit. And we already know the answers to these, so I'll just skip that step. So it'll be 3 plus 9, which ends up being 12. And it's the same thing for subtraction. It's not going to make a difference. So if this was subtraction, then this sign will be also be a minus sign. So it's the same thing. For multiplication, again, it's the same thing. So it will be limit as x approaches a for say f of x times g of x. So when you're putting the limit sign in, you just multiply the two. So x approaches a for f of x, split this up, times limit as x approaches a for g of x. So it's the same thing. And that also goes for division, provided. So if for division, it's the same thing as well. So limit, but I'm going to show you. But there is one restriction. The f of x divided by g of x. The restriction is like you can split this up same way. Like so, it'll be limit f of x over limit. Okay, I forgot the x approaches a for g of x. But this has to be provided that g of x, the limit for g of x, does not equal 0. Because if it equals 0, then it's not solvable. It's like it's an asymptote, if you recall. And yeah, these are pretty much the basic properties of the limits. And next lecture we will talk about how we can use these properties in helping us like evaluate them. Thank you for watching. This was provided by Academy of Higher Learning. Please visit our website and support us. Thank you.